this is Sung, and I'm the Principal and Director of Sky Academy. In the last episode, what we did was we looked at intersecting lines and working out that the point of intersection is the point, the specific point that satisfies both the first equation and the second equation. So in other words, it's going to be the solution of both. And we worked that out using what we call a method called simultaneous equations. Now there's two ways that you can solve simultaneous equations. The first way is called elimination. The second way is called substitution. We're going to go through the elimination method first, and I've got 3 examples just to illustrate how we use it. So we've got this question: 3x minus y equals to minus 5. 3x plus 2y is equals to 1, and I'm going to do that twice. And and it'll become clear why that is, and then I'll do probably a little bit harder example here. Okay, so let's have a look at this. We've got 3x minus y equals to minus 5. 3x plus 2y is equal to 1. We need to eliminate, and that's exactly why we call it the elimination, because we need to eliminate a variable. Okay, so this is equation 1, this is equation 2. What can we eliminate here from this equation? Well, see how we've got the 3x on top and we've got the 3x on the bottom? We can eliminate the 3x's by taking equation 1 and subtracting equation 2 from it. Okay, so let's minus, what do we need to do to eliminate 3x and 3x? We need to take them away from each other. So we're going to minus 1 from 2 to give you equation 3. Minus 3x from 3x gives you 0. And then you've got minus y minus 2y gives you minus 3y. Right? And then we minus another 1 from minus 5, which is minus 6. Do you see what we've done? We've taken each of these terms here and subtracted each of these terms from the term above it. Okay? And by doing that, when the left-hand side and the right-hand side are equal for both equations, the net result is that in the third equation, you will still have the two sides being equal. Okay? So you got minus 3y is equal to 6, or negative 6. And so y would be equal to 2 by dividing both sides by negative 3. So now that we know that y is equal to 2, we can substitute into either 1 or 2, but I'll substitute it into 1. So we've got 3x minus 2 equals to minus 5. 3x is equal to, bring the minus 2 over to the other side, 5 plus 2, or negative 5 plus 2 is negative 3. X is equal to negative 1. So, xy is equal to minus 1 and 2. And what that means is, this is the point of intersection between this line and that line. Does that make sense? That's the point of intersection. So that's where this line and this line will cross. Okay. In terms of this question, we're doing the same question again. This time, instead of eliminating the 3x's, what we're going to do is we're going to try and eliminate the y's first. Okay. And this time, what we're going to do is take equation 1 and equation 2, and what we're going to do to equation 1 is times it by 2, double it. Okay. So what we've got here, and let that equal equation 3. So what we've got here is 6x minus 2y equals minus 10. So do you see what we've done? We've doubled the 3x to give you 6x, doubled the negative y, or minus y to give you minus 2y, and we've doubled the negative 5 to give you negative 10. Yes? What we're going to do, and that's going to give us equation 3. And what we're going to do now is we're going to eliminate the y's. How can we eliminate the y's? Instead of subtracting this time, if we add equation 2 to equation 3, the y's will eliminate. So that's exactly what we're going to do. We're going to get equation 4 by adding equation 2 and equation 3. And that gives us equation 4. So 3x plus 6x is 9x. 2y plus negative y is 0 equals negative 1 plus negative 10. Oh, sorry, this is positive 1. It's the same equation, but it's positive 1. It's positive 1. Will give you negative 9. So x is equal to negative 1. Yes? And then we substitute back into the equation. Sub x equals to minus 1 into 1, equation 1. Now, you notice that I'm substituting back into equation 1 a lot. Doesn't have to be equation 1. You could just as easily substitute into equation 2 and get the same answer. And why is that? Because the point of intersection is going to satisfy both equations. Yep. So let's have a look at that. So minus 3 minus y equals to minus 5. Bring that over to the other side. Minus y is equal to minus 5 plus 3. And this time minus y is equal to minus 2. Y is equal to 2. Therefore, x, y will give you, what is it? Minus 1, 2. So do you see how we've got the same answer, but in this case, we've eliminated y. In this case, we've eliminated x first. Alright? So let's have a look at this equation. It's not as easy because there's on the first hand, there's no real way of eliminating anything simply. Right? So what we can do, there's two ways we can do this. Eliminate x by multiplying the top equation by 7 and the bottom equation by 2. And then we both have 14x as an x factor. As an, sorry, not as an x factor, as an x. I'm thinking of the show. We have 14x for the x coefficient, which means it'll allow us to eliminate, or we can eliminate y by multiplying the first one by 3 and the bottom one by 5. Right? So let's eliminate x. Right? So I'm going to take the first equation and multiply by 7. 7 times 2 is 14. 7 times 5 is 35. 7 times negative 3 is negative 21. And that we get by taking equation 1 and multiplying by 7. Yep, and that gives you equation 3. Then we're going to do equation 2 by multiplying equation 2 by 2. So that's 14x plus 6y is equal to 8. And that we get by taking equation 2 and multiplying by 2. And that will give you equation 4. Does that make sense? Alright, so what we do now is we can take equation 3 and take away equation 4 to give you equation 5. Take it away. 35 minus 6, what's that? 29y. Yep, because the 14s will cancel. Take away 8. Negative 21 minus 8 would be negative 29. So y is equal to minus 1 all of a sudden. And then we can substitute this minus 1 back into equation 1. I just like to do it into equation 1 because it's just convenient and it's just a habit. But whatever will be the easier equation to get an answer from is the one you go with. So 2x plus 5 to the times minus 1 equals to minus 3. 2x minus 5 equals to minus 3. 2x is equal to minus 3 plus 5. 2x is equal to 2. X is equal to 1. So, for this question, xy is equal to 1 minus 1. Okay? So that's how you do simultaneous equations by elimination. In the next episode, we'll do simultaneous equations by substitution instead. Okay? So thank you very much for watching.